Welcome to the 6th video of our series. In this part, we focus on modeling the flywheel. You will learn how to cut volume from a body by extruding into it. This way, we create one of the holes in the flywheel. Next, we arrange these perforations circularly around the axis of rotation using the circular pattern function. Let's go. We start with a new sketch on the YZ plane. By the way, you can select some commands directly from the toolbar. First, we draw a center line from the origin with a length of 10 millimeters. This line will later serve as our axis of rotation. If a dimension is in the way, you can easily grab and move it with a left click. Next, we draw the contour that we want to rotate later. To do so, we select the line command again and use the snap on the Z-axis. Move the mouse from the origin along the Z-axis to facilitate positioning. This does not create a constraint, but it helps us with alignment. Now draw a horizontal line to the right and enter a length of 6 millimeters. Next, draw a vertical line upwards. This line is confirmed without dimensions. Then, draw a line to the right with a length of 4 millimeters. Then draw the line vertically upwards again, this time without a dimension. In the next step, create a horizontal line to the left and specify a length of 9 millimeters. Then, draw the line slightly downwards and add a small offset by drawing a horizontal line back to the Z-axis. For this, move the cursor briefly back to the origin to use the snap on the Z-axis. Finally, draw the line back to our starting point to create a closed contour. Our sketch is not fully dimensioned yet. To change this, we press the shortcut D to open the dimensioning tool and add the missing dimensions so the sketch is fully defined. We add the missing dimensions by dimensioning the horizontal lines to the center line. For the central hole, we specify a diameter of 8 millimeters. The larger recess gets a dimension of 36 millimeters. The overall diameter of the flywheel is defined as 50 millimeters. If a line unexpectedly shifts, we can briefly end the dimension command using the escape key and click and hold the line to drag it to the desired position. Finally, we dimension the shoulder with a diameter of 12 millimeters. Furthermore, we place a point coincident with the Z-axis to fully define and correctly align the sketch. We finish the sketch and execute the rotate command to rotate the profile around the center line, creating the basic shape of the flywheel. Next, we add the through holes. For this, we could either use the drilling function or cut out the material by extrusion. In this video, we focus on cutting out and will learn this method in detail. First, we create a new sketch on the front of the flywheel. Here we draw a circle starting from the origin with a diameter of 24 millimeters. Then we mark this circle and change the line type to construction line to use it as a reference. Next, we draw another circle with a diameter of 10 millimeters, which lies on the previously drawn construction line. To precisely set the position of the new circle, we place the center using the coincidence dependency on the x-axis or y-axis. Once the sketch is completed, we select the extrusion command. We select the circle and pull it through the body. In the extrusion menu, we set the extent type to all. The extrusion type is automatically set to cut as we are extruding into the existing body. This removes material from the existing body, as is clearly shown by the red preview. After completing the extrusion, our first through hole is finished. In the next step, we want to replicate our through hole and arrange it evenly in a circular pattern. For this, we select the command circular pattern under Create Arrangement. In the menu, we set the object type to Features and directly select our previously drawn through hole in the component. Alternatively, we could have chosen the extrusion in the construction history. Then, we set the x-axis as the rotation axis. If you select one of the lateral surfaces or circular contours, Fusion automatically selects their central axis, which would lead to the same result. The new holes are now arranged around this axis. For the number of elements, we enter the value 4 so that 4 evenly distributed holes are created. By the way, we can exclude individual holes from the arrangement by activating the Suppress checkbox and selecting the corresponding holes. Furthermore, we could set the distribution to partial and change the angle so that the holes are not distributed over the full 360 degrees. Finally, we confirm the settings with OK. This completes the circular arrangement of the through holes. For the 0.5 millimeter chamfers on the through holes, we could now select all 8 edges individually, or we can directly select the 4 cylindrical surfaces. When selecting surfaces, all edges of the surface are included. We can also deselect 3 of the cylinder surfaces again and only chamfer the first hole. After that, we simply move the chamfer element forward in the construction history and edit it with a double click. Here we select the chamfer element directly in the part or in the design history by holding down the Control key. This automatically transfers the chamfers to all elements of the array. In this way, the fillets can be efficiently applied to all through holes without selecting each edge individually. Lastly, we add the outer chamfers on the component as well as the chamfer on the larger circular groove. Here too, we can select the corresponding edges one by one and confirm the chamfer with a dimension of 1 millimeter. Since the flywheel is made of steel, no further material adjustment is necessary. Now we save our design to secure the changes made. Congratulations! You have successfully designed the flywheel of our air motor and learned about the circular arrangement and cutting out. Have fun with our other videos and the new features that await you.